We've got so much going on here. So this is Module 4, Subtopic 4. We're now using the triangle mid-segment theorem to prove something about trapezoids. It's good to back up here and go back to this mid-segment theorem. Here it is over on the right, the triangle mid-segment theorem. We've got a triangle here, and the mid-segment, I'm going to cut that side in half, and I'm going to cut that side in half, attach a segment between them. This is called the mid-segment right here, and it's got some special features, or it creates some special things. The mid-segment of a triangle is parallel to the side it does not intersect, so that means the side it does not intersect is this, what I call the base, and it's parallel, and it is 1/2 of that side's length. So if this side length here is x, this mid-segment is 1/2 x. That's going to be crucial, because we're going to use that in this proof about trapezoids. What do we got here? Whoa, the trapezoid median theorem part 1. Median of a trapezoid is parallel to the bases. The median is kind of it's a analog or similar to the mid-segment in that it cuts the trapezoid opposite side into equal pieces. So line 1, given. We've got AB parallel to CD, and MN is the median. Then, line 2, we can construct line K through M that is parallel. It's not shown here, but I'm going to put it in here. This is now line K, and it is parallel to CD. By definition, it's that we're making... Actually, not by definition, by construction, we're making it so that it's parallel. Now, line 3, K is parallel to AB. That is because wait a second, I'm drawing a blank here. Didn't I say K is parallel to AB because... Oh, whoa, K, so AB is parallel to CD. This line K is parallel to CD, so by really transitive property of parallel lines, we can say that K is parallel to AB. They're all three parallel together. Line 4, K passes through P because, thank you for that reason, a line parallel to a side of a triangle that runs through the midpoint of another side runs through the midpoint of the third side. So if it's parallel and if it hits one side, it then cuts the other side into equal pieces. I'm going to put congruent pieces there. K also passes through, there's line K again, passes through N in line 5. And that's because a line parallel to a triangle, now we're looking at this triangle here. We were looking at this one. Another side runs through the midpoint of the third side. So what's happened here is we've made a trapezoid into two triangles and used the mid-segment theorem for the upside down one and the right side up one. Line 6 now, what's happened? CD is parallel to MN, which is also parallel to AB. The median of a trapezoid is parallel to the bases. So this median here ends up being parallel to both base 1 on the top and base 2 on the bottom. For number 2, a median's length is the average of the base length. So this is similar to the triangle mid-segment theorem. Now we got the trapezoid one. ABCD is a trapezoid. That's given. Do we have all the pieces in there? It's parallel. We've got that. And we want to prove that MN is the average of this side and this side. Okay? From the trapezoid median theorem that just happened, we know that that middle, what's it called, the median is parallel. Just proved that. And line 3, that MP is a midsegment for ADC. That's because of the definition of midsegment, I believe. Cuts it into equal pieces. Now, we look at one triangle. MP is 1/2 of, here's this triangle. So MP is 1/2 of this one, DC. And similarly, PN is a midsegment, so it is 1/2 of AB, because those are two triangles. Very clever to split that trapezoid into two triangles. Now, step 5, MN is equal to MP and PN. That's just looking at a segment into two different pieces. That's the segment addition postulate. Now, so what have we done? We've got MN, and we're looking at it from MN is 1/2 of DC, PN is 1/2 of AB. We are substituting this in for MP, and 1/2 AB in for that. That is substitution. So what's happened here? A median's length is the average of the base lengths. So in a trapezoid, if this is X and this is Y, the length of this is 1/2 of their sum, the average.